The omega, that's our angular speed, how fast an angle is changing. What has to be true about your theta for that to work? Radians. Linear speed is how fast your arc length, or the distance on the outside, is changing. And then we did V equals R omega to go back and forth between the two. What I really, really want to encourage you to do on these problems is write out the information given. If you make a list of what information you have, they become very simple. If you're just trying to stare at a problem and magically know what numbers to put in your calculator, you're going to struggle. Okay, so the more you write down, the better off you are going to be here. Let's take a look at this problem. Yeah. Extra handouts box and let's do. Suppose that P is on a circle with the radius of 15 inches. And ray OP is rotating with an angular speed of pi over 12 radians per second. So let's take a second and just write down the things I know so far. We have radius equals 15, so I'm going to write down R equals 15 inches. Rotating with an angular speed of pi over 12 radians per second. Okay, what variable is angular? The just angle itself is theta, but angular speed is like your velocity, so that's our omega. Part A. Find the angle generated by P. So find the angle. That means we are finding theta. So I'm going to write down theta equals question mark in 10 seconds. So 10 seconds, that would be my time. All right. Take a look at your formula list. Now, all of the formulas that we have to this point, they will all be on your formula sheet on the test. I am wanting theta, so I have to pick one of my formulas that involve a theta in it. Which one do I have the other information for? Like, do I have S equals R theta? Do I have that information? No. Do I have any information about the area? No. Do I have information about my omega and my time? Yes. So if you write out what you have, you can look at your formulas and see which formula is even an option. So I prefer to write down what formula I'm using. So my omega is pi over 12 equals theta over 10. You have a couple options here. I have some people that really struggle with units when they get to their final answer, and so they like to write their units in the problem. This pi over 12, you could put, that's pi radians in 12 seconds. This is 10 seconds. When I'm solving for my theta, what would we do? You can cross multiply or even just multiply your 10 over to get your theta by itself. You don't have to include the units within your problem. That part is up to you. But it does seem to help some people because they can see right here those seconds cancel out. So we have 10 pi over 12, or 10 over 12 would reduce to 5 pi over 6. My units there, if you wrote your units in the problem, you see the only thing we have left is radians. Radians we know are the optional unit. You don't have to write it. If you don't put units, I'm going to assume it's radians. Do you guys like me writing my units in the problem, or do you want me to not? You don't know yet? Do more examples and see. Part B. Find the distance traveled by P along the circle. So point P is outside on the edge of the circle. If I want the distance it travels, what variable is that? S. And we're still dealing with the 10 seconds. Okay. So now I need something involving S. Okay, I can do V equals S over T. Do I have all that information? No, I don't have my V. I have S equals R theta. Do I have that information? Yeah, we do. Because we have the R from the original, and we have theta from part A. So if you take 15 times 5 pi over 6, 25 pi over 2. Units, if you remember from before, S and R will always have the same unit, so we should know it's inches. You could think, if you take inches times radians, radians are the extra unit. If you multiply it with something else, the radian will disappear. If you don't have any units left, we put radians in. So this is just 25 pi over 2 inches. Part C, find the linear speed. Linear speed is what variable? V. Of P in inches per second. So, I need V. I can do V equals S over T, or V equals R omega. And it looks like we really could do either of those. We have the information. So do you want to divide or do you want to multiply? Multiply. So V equals R omega. So in part A, we knew the R was 15 inches. Omega was pi over 12 radians per second. So we get 5 pi over 4. The units, inches times radians, that radians will just disappear, so it's inches per second. You could also get that just by thinking V is a linear distance. We knew we were measuring it in inches, and our time we're given in seconds. How do you feel about that one? I really think it helps. You know, just writing out your formulas, writing out what you have, then you can look and see which formulas are an option for you. Let's just keep practicing. So a belt runs a pulley of radius 5 inches at 120 revolutions per minute. So the things that I have, radius is 5 inches, and then I have this 120. Your units are a big clue here. My units were a rate. If it's something per something, it's either V or omega. If I'm talking about revolutions, is a revolution referring to the distance on the outside of the circle or an angle? So a revolution just means you spin all the way around, right? That doesn't tell us how far you spun, like in inches or centimeters or anything, does it? But a revolution says all the way around the circle, which we know is 360 degrees or 2 pi. So when I talk about revolutions, I'm talking about an angle. So revolutions per minute is an angular velocity. So angular velocity, it'll either be radians per something, degrees per something, revolutions, or rotations. So those are really the only options I can give you there. Part A says find the angular speed. Angular speed is just your omega in radians per second. Okay, just like theta has to be in radians for it to work, if we're going to use omega anywhere in our problem, it has to be in terms of radians. So this one, we're really just converting this. We know our omega is 120 revolutions per minute. I want to get radians per second. So to get revolutions into radians, what do? We want 2 pi radians over 1 revolution. Again, we have to go into radians, not degrees. Okay, now I need to change minutes into seconds. So we can say 1 minute is 60 seconds. Okay, so you're doing 120 times 2 divided by 60, and we get 4 pi radians per second. So part B, find the linear speed. What variable is linear speed? V in inches per second. Okay, so my options for V. V equals S over T. Do I have S or T? No, so that's not really an option here. Or V equals R omega. Do I have those? Okay, so that's what I'm going to use. Okay, so my radius was 5 inches. Omega, we have 2 options. We have omega 2 different places. I said up here it's 120 revolutions per minute, and here it's 4 pi radians per second. If I'm going to use it in the problem, do I want it in terms of revolutions or radians? Radians, always. If you are going to use it in a calculation, it has to be in radians. So I'm going to use the 4 pi radians per second. So 5 times 4 pi would just be 20 pi inches per second. And again, I don't care if you write the units within your problem, just as long as you can put your units on your final answer, just however you prefer. Any questions on this so far? A satellite traveling in a circular orbit 1,600 kilometers above the surface of the Earth takes 2 hours to make an orbit. The radius of the Earth is approximately 6,400 kilometers. Approximate the linear speed of the satellite in kilometers per hour. All right, so let's see what information we're given here. What do we have? What did I give you in the problem? The radius. Now, be careful with this radius. You want the radius from the center of the Earth all the way out to the satellite. So what do I need to do? Add. We know to the edge of the Earth is 6,400, and then the satellite is 1,600 beyond that. So if you add those together, the actual radius of the circle we're looking at is 8,000. Did I give you any other information? I told you that it takes 2 hours to make an orbit. Alright, So 2 hours, that's like a time, right? In that 2 hours you made an orbit. What does that mean? One complete revolution. So that's telling me my angle is 360 degrees. I'm just going to go ahead and say 2 pi radians. So telling me how long it took to make an orbit gave me two things. It gave me a time and how far you traveled. We went all the way around. So part A wants the linear speed. Linear speed is v in kilometers per hour. So my options for v. V equals s over t. I have a time. Do I have my s? No. I could also do v equals r omega. I have my r. Do I have my omega? No. So I'm going to have to find something else first. Which one do you want to find?
Omega.
Omega? Okay, how do we find omega?
Omega equals theta over pi.
Alright. And you could find s as well. It doesn't make a bit of difference here. So my omega is 2 pi over 2, which is just pi. What would the units on that be? 2 pi was in radians per my time was in hours. Okay, so then we can do v equals r omega. So you get 8,000 pi. Your units, my radius was in kilometers per hour. Okay, that one I didn't write my units in my problem just to show you your options. You just have to take a little bit more time at the end to think about what your units might be. Part B. Approximate the distance the satellite travels in 4.5 hours. If I'm talking about the distance the satellite travels, what am I referring to? S. Okay, can I just do the S equals R theta from up here? No, because this theta is only when your time was 2 hours. Here, I know that my time is now 4.5 hours. Okay, so I can't do S equals R theta because I don't know the angle it traveled. What else has an S in it? V equals S over T. Do we know V? Yeah, let's plug into there. We just found V in part A. So you would multiply over your 4.5. And what does that give you? What would my units be on that? Oh. Your clock problems, you guys love those, right? So, I want the angular speed. What variable is that? Of the minute hand of a clock. I gave you no other information. So that was helpful. What can I do? What formula would you think? Omega equals theta over t. Okay, this will work. What we have to do is pick a theta and a t that go together. In other words, I could do this problem one way, and you might pick a different theta and t and be okay. So pick a nice angle. If you're thinking about the minute hand of the clock, what would be a nice angle? 90 degrees. That would be what in radians? Pi over 2. If the minute hand travels pi over 2, 90 degrees, how much time has passed? 15 minutes. Okay, so you could have done pi. You could have said it traveled 180 degrees, and then what would your time have been? 30 minutes. You could have said 2 pi, and then your time would be 60 minutes. You might even say, if you go theta equals 2 pi, and your time is 1 hour. So units are going to be very important on this answer, because I could technically give a speed in radians per second, or radians per minute, or radians per hour. So you have to be very careful here. So using the information we did, that's pi over 2 divided by 15 minutes. And what's that give me? Pi over 30. And units, pi over 2 is radians per minute. So in a problem like that, you just have to pick a nice angle and the corresponding time. Is that one okay? If you were trying to do your calculator on this, what you would have to do is 1/2 divided by 30. You just don't put it in the pi. Or sorry, divided by 15, not 30. Find S if R equals 9 yards, omega equals 2 pi over 5 radians per second, and t equals 12 seconds. Random thoughts, because it just popped in my head. What if I had said t equals 12 minutes here? What would you need to do first? Change it, because this is radians per second, your time needs to be in seconds. So always do make sure that your units match. Okay. Sorry. So I need S. Let's look at my options with an S in it. S equals R theta. We have an R. Do I have a theta? No. Okay. V equals S over T. I have a T, but I don't have S. So we have to find something first. Which one do you want to use? Which S equals R theta or V equals S over T? Okay. So in order to use this, I'm going to have to first find my theta. Looking at my formula options, what could I do? We have an omega, we have a time, so we could use omega equals theta over t. Two pi over 5 equals theta, which I don't know, divided by time. Again, make sure those units, this is seconds and that's seconds, so I'm okay. Multiply over my 12. I get theta to be 24 pi over 5. So now S equals R theta. If you take 9 yards times 24 pi over 5 radians, what are my units going to be at the end? Yards. Yards are S will have the same unit as R. Alright, so what do we get? 9 times 24 over 5. To 16 pi over 5 yards. Any questions? So this section is just all that practice using our formulas. I am done. So, the homework. I am not actually going to collect these until Wednesday. My plan tomorrow, I am going to give you some class time. I'm going to give you a workday in class, but I'm also going to go ahead and pass out your Chapter 3 study guide. So if you're not done with this homework, you can work on it. You can work on your study guide. Wednesday is our review day for the test, so we can work on our study guides, go over things together, whatever we feel like we need to do, and then test on Thursday.